All right, so those are some of the clinical issues in resuscitation. What I want to talk about now is once we've got processes in place, what do we do with the information? When we want to make a change, how do we make it well and measure our improvement? So I want to talk a little bit about just kind of very basic fundamentals consistent with this 101 level class about doing data collection and quality improvement in resuscitation. So I think there's a lot of misunderstandings that people tend to have, at least in my observation, teaching quality management for a long time now. And people will sometimes have some confusion about terms, so I just want to level set us on some basic principles related to the terminology of quality. And the first phase of quality that I think we all need to recognize is quality planning, and that is, what is the process that we want people to follow? How do you want me to work this resuscitation? How do we want the system to perform during resuscitation? How does dispatch do what they're supposed to do? Medical first response, ambulance, emergency department, cath lab if they're going to the cath lab. Exactly what are the steps we want everyone to follow? That's quality planning. Okay? Then I often hear people talk disparagingly about quality assurance. Well, we don't do quality assurance anymore, we do quality improvement. Well, I would like you to reconsider that notion, because what quality assurance is supposed to be about is seeing if people are following the process. We've designed a protocol that says you give this amount of a drug, or you do this step, then that step, then the next step. How well are people following that process? You've taken such care and effort to design. There's tons of research behind making these ILCOR and AHA recommendations. Are we following what was recommended? That's what quality assurance is about. Are we complying with the process? And so that would be making sure that through an audit process, whether you do it for software, which is generally preferred just because of the time savings, but however you do it, you need to make sure we're following the process, so that when we look at the performance of our process, whether it's in terms of our survival from cardiac arrest, whether it's about our pre-shock pauses or compliance to target compression rate, etc., are we following the process as it was designed? So then we can decide how well does our process perform, which then leads us to quality improvement. And quality improvement is this whole notion of, this is how my process is currently performing, and I want to make a change. I want to change the fundamental design of the process to do something else, because I think this change will make the process work better. This is in effect a hypothesis. Your hypothesis when you change a protocol is that performance is going to get better. Otherwise, why would you bother changing the protocol, right? So an example of quality improvement intervention is that our process previously did not use conventional ventilation associated with our resuscitation process. And based on what we've heard at some conferences, looking at the literature, talking to our colleagues, we think this whole impedance threshold device, or mechanical CPR, or high dose epinephrine or mask pants or whatever it is, at some point we thought that was the way to go, and so we made the change. It was a hypothesis, and that is the quality improvement intervention, okay? So there's some clarity around that. And to look at it visually, imagine on the vertical axis, bad is up, okay? More errors, higher death rate, what have you. And so when you don't have a plan, you're going to have all kinds of variability. You don't have a protocol, just go out and resuscitate people, or just go out and manage STEMIs, but there's no particular protocol other than go out and do good things, okay? So we've got high variability without a clear process design. So we do quality planning, and then we make sure everyone is complying with the process. That's our quality assurance. Now we'll get consistency. And for those of you who have ever used a statistical process control chart, think of those bands above and below that squiggle line there in the quality assurance phase is your upper and lower control limits. That's the expected range of variability of performance, okay? Now, when we introduce our change, we're intentionally trying to change the performance. So in this case, what we think is going to happen is when we introduce this variable, the line is going to go down, okay? And perhaps that will be what happened. It might not go down, it might go up. We might see paradoxically that outcomes become worse. We thought high-dose epinephrine was going to be better. We thought mask pants were going to be better, etc. And we might find that indeed quite the opposite is true. But unless we measure it, we really don't know. Which kind of gets to this whole paradigm of you can't manage what you can't measure. You can't improve what you can't measure. So it's important then to figure out where you're going to spend your time and energy. You want to measure what matters. Now, time is an important factor with many things in resuscitation. And one thing that I think the literature is showing very strongly that matters in resuscitation is the whole pre-shock pause issue. And you don't have to have a lot of sophisticated software to do this. Most any monitor, even a LifePak 5, I don't think anyone is still using LifePak 5. I personally loved the technology, but nonetheless, that was a bygone era. But even on LifePak 5, you could measure pre-shock pauses. You could see where the artifact from CPR stopped, and you could see when the defibrillation occurred, and you could measure that time interval. That's an important thing to measure. The literature shows us that. We also know that chest compression quality is important. So imagine on this slide that this reflects the start and ROSC for resuscitation. I mean, it probably actually doesn't, but imagine it does right at the very bottom line of the graph there. So all of those places where we see the red squiggles going up and down, each one of those is a compression, and the gaps is where compressions were stopped. So if we looked at that as a ratio, that would be our compression fraction, okay? We know that matters, so we want to measure that. We know that leaning on the chest matters, where we don't get complete recoil of the chest. That's something that's good to measure. We know that measuring ventilation matters, and we can quantify that by looking at the CO2 waveform and actually counting the ventilations. So we can get all this information together depending on which brand of defibrillator you're using, and if you've got the analytics accessories to go along with it, whether it's an accelerator or a magnetic field device like with True CPR, the hockey pucks with Zoll and Philips, whatever the case may be, you will get this kind of data back showing the compressions, the depth, all of those sorts of things. Now, once you get that report back, you can look at it a couple different ways. You can look at individual cases and provide feedback to the individual crews. But rather than just the ambulance as the crew that delivers the patient to the hospital, I would encourage you to share that feedback report with that kind of data we just showed before to everyone involved in the case, including dispatch, including non-transport medical first response. If you can arrange the meetings with some sort of QI on resuscitation and whatnot, include the emergency department. If the patient went to the cath lab, include the people from the cath lab. Because I'll tell you something, especially our hospital colleagues need to understand the metrics of compression quality, because in general, they're a little bit further behind EMS. So this is an opportunity for us to help them and get them to understand how to understand this data, interpret the reports, and provide the feedback. So you want to share it with the whole team, and you want to share it sooner than better. And there's a lot of different workflows that can surround this, but if you take the notion that giving feedback to people sooner is better, what are some of the best practices around that? I think a lot of organizations will try to get it back, by the next shift, but I've heard stories and whatnot from several different agencies about how they've really amped up their workflow by getting the feedback reports done within an hour or a few hours. And the ways they do this 24/7, 365 is instead of relying on just the quality improvement person in the organization to do the analysis, they'll have training provided to several people on every shift. And so once a cardiac arrest is detected in the system by the file uploading into the server, whether it's LifeNet or RescueNet or whatever the case may be, the people that are on shift who have that assigned responsibility will be notified. And by having a couple of them, odds are that somebody will not be on a call. They'll download the data file, they'll run the analytics package, and they'll send the reports back out to the crews, again, sometimes within a matter of hours. And this is important because now the case is fresh in everybody's mind, and you'll be able to identify, what might have been going on to explain this long pre-shock pause or this long pause in compressions, etc. And say, I remember this distracting factor happened, and we kind of fumbled the ball there. We should have made sure that we kept on the chest during this, and it just kind of reinforces the whole notion with closing this feedback loop as quickly as possible. And then you can, as necessary, as the QI person or the analyst, for that matter, if they're trained on how to do this, provide some individual, tips or pointers, or at least point out, here you had long compression pauses, here you had long pre-shock pauses, but ideally, the crews themselves will become familiar with the report and the interpretation of the report, and they'll do their own analysis. And I'll tell you, the tendency will be that they'll be much harsher on themselves once they can self-interpret the reports than probably the auditor or the QI manager or the supervisor would feel comfortable providing the feedback. So that's just human nature and something to take advantage of. And then when you have one of those individual reports that illustrates a particular point very well, here we see a case perhaps that shows almost, perfect compression fractions and minimal interruptions. And you can say that this is where the crew is using this new hovering technique, where we don't take our whole bodies apart, but we just make sure our knees are separated. We just lift off the chest, slip in the compression, and go right back on again. So those are some of the sorts of things you'd be able to do in sharing that report on individual cases. But there's also power in sharing aggregated data. So lump all of those case reports together and get tables of analysis. And even for the individual crew, you can then show the crew's performance in changing their compression fractions over time, maybe even contrasting it, and here's where the rest of your colleagues in your agency are performing. And then when CARES starts adding this data to it and you're participating in CARES, you can contrast that, and here's the national average for compression fractions. And seeing those gaps between your performance and the aggregate performance is very powerful feedback that influences behavior. You can also then lump it all together and say, this is how our organization, as an individual hospital or non-transport medical first response agency, perhaps a fire department or an ambulance service, this is how our whole agency is performing, and compare that to other agencies. And even if you don't compare it to anybody else, you can see how your agency is perhaps improving or declining or staying flat over time. Very powerful feedback. So in that context, now we want to figure out, okay, here's what our performance is. How do we make it better? Now, I've taught Six Sigma for many, many years, and my experience in talking to people about Six Sigma is they tend to dramatically overcomplicate this issue. Think of Six Sigma not as some, nerdy, statistically, sophisticated method of trying to do improvement. Just think of it as just kind of a roadmap to follow. When you've got a problem, how can you fix it? And it uses a process called DMAIC. And DMAIC is just an acronym for Define, Measure, Analyze, Improve, Control. So the first step is define the problem. So looking at our data from those feedback reports, we see that maybe the agency or an individual crew has a problem with long pre-shock pauses, let's say. So we've defined the problem. This is what we want to focus on. This is what we want to fix. The next step, measure, is where are we now? What is our current level of pre-shock pause in aggregate for an individual crew, whatever it might be? And then if we see that our performance is lacking, what factors might be responsible for having this long pre-shock pause or this low compliance to target compression rates? Whatever the case may be, think about what are those factors that seem to be influencing it. And then you come up with an idea. Based on reflecting on this or studying it a little bit more detail, I think the problem is that crews just don't realize how long they're taking from the time they release the chest until they actually deliver that defibrillatory shock. They just don't realize how long that time is really taking place. And so maybe we'll provide a feedback report or something to improve that. So we'll make that intervention. Maybe it's feedback reports, maybe it's a timer of some sort. Whatever you come up with, you'll go ahead and introduce that improvement intervention. We'll talk about that again in a minute. But the final step in DMAIC is, now you've been thinking about this study in a great level of detail. You've been analyzing your data. This has been your focus for your improvement project or your improvement project team. You'll also be in a great position to think of, how are all the ways we could screw this thing up? So you've been pushing this rock up the hill and you've made some progress. What are all the ways that might screw this up and get it start rolling down the hill? So before the rock starts falling down the hill, let's figure out now, if that happens, what are the most likely reasons it'll happen, and pre-plan interventions to fix it. Because odds are, for most types of problems, you can probably imagine with reasonable accuracy how your crews are going to screw this up, how your organization is going to screw up, how the system is going to screw up. Whether it's by simple fading of memory from an education session, whatever the case may be, now is the time to think through what are the likely ways we might mess this up and try to pre-plan some interventions. So going back to that improve phase, it's simply coming up with an idea that you think could make things better, and then you make that intervention. Now, part of the challenge is there's a whole host of things you could potentially do to fix any given problem, how you could skin any given cat, if you will. So what I would suggest, particularly if you're relatively new to quality management and improvement science, is that you use some filters. No matter what level you are, you got to think about, what can I reasonably change? What's in my control? But I would suggest that you focus on improvement interventions, again, early on in your growth curve in doing improvement science, to things that are simple, inexpensive, and fast. And then try it. So if you're confronting an issue of low survival rates in cardiac arrest, what are the factors that might contribute to it? So if you think through simple, fast, inexpensive, what are those things on the list that might drop out? Okay. So of those, thinking what's simple, fast, inexpensive, well, the last three are probably reasonable candidates. You got to pick one. So let's suppose we picked this whole pre-shock interval idea. Well, you've done, by definition, the define phase. This is the problem that we want to fix, pre-shock pauses. And from a measure standpoint, you get your baseline. We'd like it to be less than 5, but we're, up around 14 seconds. And so you've got several different options. And again, which ones would be fast, simple, and inexpensive to implement? There's a whole lot of technology changes we could suggest to our manufacturers that might support faster pre-shock pauses on a totally automated basis. I think that's a worthy project to pursue, but probably your agency is not in a position to change the R&D department at any one of the defibrillator manufacturers. So again, that might be something that some organizations are in a position to influence. Maybe not yours, maybe not mine. PITCA strategy, that's a good idea, but that's going to take some time. It's going to have some cost. But if we simply started providing feedback reports, going back to that notion of, I don't think the crews realize how long they're spending, in terms of time from when they come off the chest to putting on the energy, pushing the button to defibrillate. If they simply knew how long it was taking through some feedback, maybe that'll help. So you do that intervention. And so imagine this graphically, going back to our graph again, but now we have pre-shock pause duration specifically on that vertical axis. And so before we, really even put pre-shock pauses on the radar screens of our providers, we probably would see great variability. And then we say, this is our goal, less than 5 seconds on a pre-shock pause. Now we have quality planning. We have a process we want them to follow and a target. And we provide, information back, and we see that we've got a pretty consistent process. But now we've come up with the idea, okay, now let's try to very quickly get the feedback reports out to the providers and see if that works. And I think in many cases it will. Maybe it will, maybe it won't. But this is the general process flow for doing quality planning, quality assurance, and quality improvement. And the nice thing is this isn't just about resuscitation, obviously. You can apply this to STEMI, stroke, any sort of care or process you're doing, medical or non-medical. And so that's just what I'd like you to take away from this in terms of doing data collection and quality improvement in resuscitation, is just a general understanding of quality management and improvement science, how similar it is in many respects to the scientific method. And even though you're not planning on submitting a peer-reviewed publication, you're generally using the same concepts and applying them to common everyday process challenges in your organization. So we're right at time. So if anybody has any questions, we'll stick around for a moment to try to answer those. So thank you very much.